Hi, this is Pedro from OpenBOM, and today we're going to talk about Agile new product development. So let's see on today's example, we're gonna prototype a new soldering station. It has an aluminium case, so it's a premium product. It has a top plastic cover that is sent from a supplier, and we're going to also collaborate with ECAD, with Altium, with PCB board integrated with SolidWorks. So in this case, we have a part file for a simplified version of that component. So this component will be a machine, but first let's talk about Agile versus Waterfall. So usually the Waterfall process, every stage is sequential. So you design, you create a bill of materials, you go for purchase for contract manufacturers, you assemble, and it takes a long time to go all through those stages. The Agile approach, the goal is to bring changes early on to stakeholders. So you do a lot more iterations more quickly. So you design, create a BOM, purchase assembly, and you create those iterations faster. So you can collect feedback a lot earlier in the process, and you can gain time. So in this case, let's simulate MCAD in SolidWorks work together with Altium on ECAD. So I'd say the engineer is planning this for component to be machined, and it's doing some simulation on CNC. So we can continue doing that happily, and we will move concurrently. The Altium team is working at the same time. So look how it's easy to, let's move into Altium on the left, and look how it's easy to have an integrated BOM from ECAD. So first, there's no files to open so just a click of a button, you can locate this bill of material uh, instantly, directly. So you have the full BOM updated and created with all components. And it's very easy to generate. So you can generate that and update it anytime with the update BOM command. So all these changes can happen concurrently, and all these iterations can happen at the same time. Engineers and mechanical engineers and electrical engineers can be all seeing the same information. Information will be updated real time. So they will see the which user it's on which cell, which row on in OpenBOM, and you can see changes just happen um, real time. If we go back to the engineer tool, we can see that bill of materials is updated from Altium. And again, this happens real time too. So let's move back to the top assembly and see the full BOM from here. And you can see that you have access to engineering BOM there, ECAD BOM over there. So you have full integrated bill of materials from MCAD and ECAD, and you gain time. At the same time, the contract manufacturer, it's going to take care of the 3D printing component. So we're going to order the plastic top cover. We're going to order it for 3D printing. So let's go and order this for the contract manufacturer. So let's locate the soldering station. There's already a order going on to create one prototype. And we have also order per supplier, the quantity that is required. So we have quantity on hand 2, quantity required 1. So we have no quantity gaps. We have a quantity gap for this component here. And it's very easy to create a purchase order to this supplier. And this also can happen, it's happening at the same time as engineering teams and electrical teams are working. So I can create a very quickly a quote for 3D printing, and he can work directly on the derived file format for 3D printing on a step file. So you can export, and then on the export file, we can include the step files. So I missed that. Let's do that again. So let's download all components and export. So we should have a zip file with all the step files inside. So it's very easy just to send this quote to the supplier, and then you can see the generated quote with different components. In this case, we're also looking to see how much does it cost to have this done outside. So the aluminium case, besides also looking to explore the cost to do it internally. So the supplier can just let's get ourselves on the steps of the supplier. So he can receive a step file directly. Notice how most CAD tools they can work and associate directly with step files. And from here, he could just start his 3D printing process. So he could just start to look for support and start to look for a 3D printing process. Notice that since we are collaborating over step files, it's very easy to then receive changes. Like if you receive a new step file, the content will update, and you don't need to lose your work that you are doing either on 3D printing, or if you are doing CNC, you're not going to lose your current work collaborating with step files. So in this example, we just shown you how it's easy to collaborate with ECAD and MCAD together, and how using derived file formats with contract manufacturers can accelerate your product development. Thank you, and see you on the next video.